Would you like to learn about some of the common mistakes that many people make when they're using their lasers? If so, then keep watching. How's it going, everyone? I'm Steve and I make everything, and welcome back to the channel where together we focus on making your world using modern workshop technologies. And in this video, we're going to focus on the top 10 common mistakes that people make when using a laser. And these vary from minor inconvenience to pretty severe problems. So you're going to want to watch this. Now, just a heads up before we get going, we're going to focus this in three areas. The first is setup, which is just generally how your laser's put together on your workbench. The second is operation, the techniques you use to get things done. And the third is materials, and that's generally, what kind of problems can you have with materials. So with that, let's get going. So we're going to start with the setup problems, and there's really only a couple of these that are pretty common. And the first one is venting. Now, venting is obviously very important in your laser. You need to get that smoke out of the inside and any toxic fumes if there happens to be anything. So you got to have generally a piece of pipe, and in most home lasers, it's a 4-inch dryer vent kind of pipe. Now, I'll put a video up above. The first video is this metal foil tubing pipe that came with my laser, and it looks just in normal light, it looks just fine, but I'll put a light on the inside of it and I'll make it pink just so it stands out. And when I do that, you can see that this pipe is actually full of holes. And if you're using it for its intended purpose on a dryer, it's not a big deal because really all that comes out of a dryer is hot air. But in a laser, all those fumes have an opportunity to escape. So what I did was replace this pipe on my laser with PVC vinyl pipe. And again, I'll show a video up above here, and you can see that is much better sealed. It's a continuous piece of effectively some kind of manufactured rubber, PVC, and it's completely sealed from end to end, which is exactly what you want. So you don't have to worry about heat here being, too much heat causing vent pipe damage. The laser just doesn't get that hot. So the PVC pipe is fine. So what I would suggest is if you're using that metal foil pipe, do what I did and put a light through it and, take a look at it, because you'll be shocked how many holes there are in that stuff. So that's the vent pipe. The second challenge you have to deal with here, the second problem, and again, it's related to venting, is most lasers for home, they have a fan, and mine has a 120 millimeter fan in it, which can certainly move a bit of air out of the inside of the laser, but it's just not enough. So what you want to also do probably is get an inline fan, and I'll show you a picture up above of my setup. And really all I have is a 4-inch inline fan that moves around 195 CFM, cubic feet per minute. And that is enough by far to see, like, you can literally watch smoke leave the laser because there's quite a bit of suction out of that. So I would recommend doing that. Again, the higher the volume, the better. There's no way you can do enough evacuation of your laser. So, the more the better. I've seen people who take a 6-inch fan with two 4-inch adapters because they can get higher flow rate through it, and you might want to consider that. The price of these fans runs anywhere from $25–30 up to $300, depending on how much air you want to move. So it's a worthy investment around venting. So sticking with setup, at number 2 on our list is alignment, and that's alignment of the mirrors. Now, if you have a Glowforge or some other kinds of lasers where there is no adjustment, you don't have to worry about this, and that's good news for you. But for the bulk of CO2 lasers, there are generally 3 mirrors and at least a lens, and those things do have to be in alignment. Now, I did an alignment video, and I'll put a link up above. Go watch that if you want to align things. I normally align my laser once a month or so, or as needed if I see the alignment looks kind of messed up. It's more important if you're doing a lot of raster image engraving, because if you watch your laser head, it's just cranking back and forth, really intently and with aggressive stops and starts. So if you're doing that kind of thing, then you do want to align more often, or at least check the alignment. And again, watch that video if you want to know how to do that. So that's the alignment problems. So now we're going to move into some of the operation and maintenance kinds of problems that you'll run into. And the first one of these is just cleaning. It's very important that you keep your laser clean on a regular basis, no more than once a month, I'd say. Pull out the grate, the crumb tray, and just vacuum the bottom of your laser out. And the other thing you want to do is clean the optics. Now, optics it's very important that they stay clean, because sometimes you'll be cutting and you'll see inside the laser case there will be all kinds of smoke. Sometimes if that stuff happens to be passing by the mirror when the laser hits it, the laser will actually bake it onto the mirror. So over time that stuff will build up, and if it gets kind of intense enough, then it will actually cause the mirror to start heating, and that will either crack the coating, crack the lens or optic, burn the coating off. It's not good. So, take the time. It takes 10 minutes maybe to kind of go through your laser with a lens wipe and clean off all the optics. Don't be shy. These things are cheap. So, if you use a separate lens wipe for each optic, that's perfectly fine. So you're not passing grit from one mirror to the next. So that's the cleaning. Okay, at number 4 on our list of laser problems, and we're still sticking in around the operation and maintenance, and this one is really kind of misunderstood and often ignored, and it's the coolant in your laser. Again, if you have a Glowforge, you can stop listening, or an Epilogue. You don't have to pay attention here, because those have closed systems where there is liquid coolant in them, and so just because you have a Glowforge, don't think it's not liquid cooled, because it is. It's just that the coolant in it doesn't have to be maintained in any way. But if you have an external cooler, chiller, or just an external circulation pump, then you do want to pull this liquid, this water, out of your laser from time to time, drain it, and replace it with clean water or antifreeze if you're using antifreeze. This will prevent the inside of the water jacket on your laser, on the actual laser tube, from getting kind of crudded up with stuff on the inside, as well as the tubing, and it allows the pump not to work so hard because it's trying to pump sludge through the tubes. So I'd say change that on at least twice a year. I change mine every 2 or 3 months. Water's cheap, at least in most countries, and it takes seconds to drain it, and I mean, you basically pop one of the hoses off the back of your laser and put it in a bucket and run the pump, and it'll drain pretty quickly. So that's the whole coolant aspect. And again, don't ignore it. It is often ignored, but resist. Just pay attention to the maintenance of your coolant system. So at number 5 on our list of common mistakes that you would make with your laser, and this one is we're still talking about operation here. This one is probably the most important thing to pay attention to in this video, and that is never ever leave your laser unattended while it's running. And that applies to really anything, but certainly some materials, paper or light woods. Those things tend to be much more flammable, and literally you can turn your back for a second and that laser, there's a fire inside. So never leave it unattended, and always make sure that you have a CO2 grade fire extinguisher at arm's reach to your laser, and just in case if there's a fire. And the reason you want a CO2 one rather than something like a foam type extinguisher is because it won't cause damage inside. It's really just CO2 gas that goes in there, and basically it runs the fire out of air. So keep a fire extinguisher handy as well. And that's the most important tip, and I can't stress it enough. Never leave your laser unattended for even 2 minutes, because fires happen really quickly if you're not paying attention. So now we're going to move into the material section of this video and common mistakes around the things you work with. And at number 6 on our list is the use of improper or unsafe materials. Now, you've probably heard about a few of these. The obvious ones are anything with like halogen-based chemicals, so that's chlorines and fluorines and bromines and iodine or iodine, depending on where you are on the planet. These things are bad, and that includes things like PVC, polyvinyl chloride, or polyvinyl butylate. These things, when you cut them or hit them with a laser, they tend they tend to outgas those chemicals, and those are certainly very bad for you. But things like chlorine and fluorine will also attack the optics in your laser, so you can actually damage your laser as well. So stay away from those. Now there's other ones that are less obvious. Some of the base metals, manganese, carbon, nickel, copper, lead, any of these things, if you hit them with a laser, they tend to break off pieces that get vaporized, and those things can get stuck in your lungs, and they're actually very unhealthy for you. So avoid any of those base metal type materials. Chromium is another one, which kind of leads into the next section here around less obvious unsafe materials. So if you're working with leather, a lot of leathers are tanned with chromium-based chemicals, and you really have to watch those. So if you're going to work with leather, make sure you get vegetable tanned leather. It's available. You can buy it pretty much everywhere now. I mentioned PVC and PVB, those types of materials. Carbon fiber, stay away from carbon fiber, because again, when you hit it with a laser, those carbon particles break off and they float around, and they're very harmful to you as well. Anything with beryllium. So anyway, that's the materials. Now, there's also common materials that you'll see that you may have heard of, like polycarbonate or Lexan. Those ones are unsafe for a different reason. Certainly if you try and cut them, they tend to get yellow, they tend to darken up, but they're also very prone to fire, so you really don't want to cut those things. And some people will, but they're generally bad. Polystyrene foam, don't be tempted to cut it. Use a foam cutter if you're going to cut that kind of foam, because that stuff, it's almost like gasoline. When you hit it with a laser, it catches fire right away. So if you're cutting a sufficiently thick piece of it, you're guaranteed to have a fire in your laser. And this is actually the most common cause of a fire in a laser, is people trying to cut this polystyrene foam. And last on this list is ABS. And ABS, when you try and hit it with a laser, it actually emits cyanide gas, which, as we all know from our spy movies, cyanide is that thing that always kills spies. Well, it'll kill you too, so stay away from working with ABS as well. Anyway, that's the unsafe materials, and hopefully you're sufficiently terrified that you just avoid those things. But in general, when you buy a material or when you use a material, always look at the chemical composition. If it's coming from a supplier, ask the supplier what the composition is. Most of these materials will have the hazardous, detail page that you can look at. So, take the opportunity to look at those and stay away from things that are really bad for you. So at number 7 on our list, and we're still focused on materials here, is material preparation. Now, you can easily just throw a piece of Baltic birch in your laser and do a cut, but quite often you'll see kind of a brown residue, and it will certainly come off with a bit of sanding. But if you just want to make your life easy, the best way to do that is to just get some 12-inch wide masking, and you can buy this stuff on Amazon, and just mask off your entire piece of material. And then when you cut it, you won't have any of that residue. Same with acrylic. If you cut acrylic, especially rolled acrylic, if you're working with rolled acrylic, when you cut it, you'll see a kind of a smoky finish on it when it's done. It's hazy, and that's actually permanently modified the acrylic. So it really ruins a piece. And the easiest way to work with acrylic that way is to do something like liquid dish soap. Just put a layer of liquid dish soap on when you're working with it. And I did this in a video on edge lit signs, and I'll put a link up above here. Anyway, that's kind of the thing when you have to think about. So really, anytime you put a piece of material in your laser, you have to look at it and go, is there something I need to do to prepare this? And usually you'll see there is. For the most part, it's masking of some sort. Most acrylics will come with a masking film on both sides, and you can cut with that. Although be warned, if you're doing engraving, you really have to peel that stuff off first. But leave the one on the back side if you're cutting through something. Leave one layer on, and just the surface you're working on with engraving, just make sure you peel that one off. Anyway, that's the kind of material prep thing, but always think about it when you're putting something in your laser. So at number 8 on our list, we have a mistake that people make quite commonly. I've made it myself many times, and I'm sure to do it again in the future. And that's around material waste. And some materials, you don't want to waste them because they're very expensive. Some you don't want to waste them because they aren't the best for the environment, or they're not recyclable in a proper way. So you want to make sure you're as efficient as possible. Now, there's 2 ways to do that. The first one is to make sure that when you're printing jobs, you're compressing your layout as much as possible. So, if you have to rotate something to make it fit a piece of material where you may have previously cut other things out, do that. It's easy to rotate parts on most laser software. So, make sure you do that. The other thing is, and this really applies to making some kind of volume production job where you're making maybe 20 or 30 of something, do a test print first. Because if you start a job and maybe you get through 10 or 15 parts of this job before you realize there's something wrong, you've just wasted a whole sheet of material. So test prints, most of us have little scraps of material around. If you have the same material as a scrap, put it in there, make one of something just to make sure it works. And you'll have a lot less disappointment, especially in your pocketbook when you're not throwing out so much material. So keep the material waste in mind. We're winding down our list. We're at number 9, and this is an interesting mistake because this one honestly is somewhat out of your power. Quite often we buy a piece of material, and I can show you a video of a piece that I have in my inventory here right now. Material that isn't flat. And, there is a tendency to try and find the cheapest material you can. And quite often those materials are not specifically designed for laser work. So you get, a typical hardware store kind of sheet of plywood. And when you cut those things, they sometimes, often aren't flat. And that's a real problem in your laser. Now, there's a couple ways to solve this. You can certainly buy, laser grade materials. Yes, you'll pay more, but you'll have, fewer challenges with it. The other thing you can do, and you've seen me do it in some videos where I have some small neodymium magnets that I put on the material, and those things are really strong, so they're enough to pull down most material. Or you can make little pegs that you can put into your crumb tray or your grate and hold the material down that way. The reason the material has to be flat, of course, is because when your laser starts working, it assumes a particular distance, focal distance, and if you have a big bump or a big hole in your material, a big dimple, your laser's not going to cut well or engrave even. So, just make sure that you're using flat materials. And it's a simple mistake, and we're all tempted to try it, and I'll tell you, you're going to fail, just like I have failed. So make sure it's flat. So here we are, we've reached the end of our list of common mistakes, and we're at number 10. And number 10 should be an obvious one. It's around material settings. And the challenge we have with material settings is depending on the material or even the laser, the material settings can be different. And like I've seen 2 lasers of the same model where the settings are slightly different. The only thing you can do in that case, if you're doing maybe volume production and you want everything to be exactly the same, is you have to build in some kind of compensation calculation. So that one is less common though, but certainly quite often the tendency is to, if you're engraving, is to engrave too dark. And I'll show a video up here where I took three different swipes at a piece of Baltic birch. One column where I adjusted the speed only from literally too much or not enough speed, so the material is kind of overbaked, to not enough where there's really not enough engraving. And same with power, same with current. If you have a laser that supports current, like the FSL lasers or K40s, any of these, you have to also consider what the variation is around current. Now, the good news is if you have a glow forge, you only have to worry about speed and power. And other lasers are the same. Some lasers have more or fewer settings for these things. But the more settings you have, the more power you have, the more capability, but the harder it is to get the settings right. So if you look at this sample up above, the ideal setting is in the center of this kind of 7 or 8 box, 7 box thing I threw together, and where all the settings kind of converge into the right, the correct setting, so that when you're doing an engrave, it looks proper. So now I did a video on this stuff, and I'll put it on the side here around material settings. And if you have an FSL laser, you can actually pull down my settings file, which has all of my materials that I use regularly and variation of engraving from 10% to 95%, as well as cuts. And if you're interested in that, then click up here and go watch that. And otherwise, we'll call this a video, and hopefully you got something out of it. So go make your world, and I'll see you next time.